Okay, so we're going to look at some other trig identities. These ones are going to be a little bit trickier because you have to start adding some algebra in that you didn't think would have been needed. So with this first one, we have sine x plus cos x. It's really like having here x plus y and then all squared. Well, if you were to use that quick sheet that we gave you before, you would have known that's x squared plus 2xy plus y squared when you expand that out. So expanding this out quickly would be sine squared x plus 2 sine x cos x plus cos x squared plus cos squared x. And this is all dealing with the left side. We're going to leave the right side the way it is. Well, the nice and fun thing here is sine squared plus, well, I'm going to group things together a little bit nicer for us because we should see it already in that one step. And that's the key here, is if you didn't see this part, it would look like a nightmare scenario. But because you have this piece here that I highlighted, well, sine squared plus cos squared because of the Pythagorean identity is this. And then looking at our double angle one, well, this is exactly sine 2x, which is where my left side is now equal to my right side. Look at this next one here. Again, it looks confusing, especially because we have cos 2x, that double angle one, and we have too many options a lot of the times. We have cos squared minus sine squared, we have 2 cos squared minus 1, and we have 1 minus 2 sine squared. Well, all those can be troubling, but what I'm going to choose is the first one I see, which is cos theta minus sine squared theta. Well, if we think about here, if we had x squared minus y squared, we could always break that down into x plus y, x minus y. By that same logic, that means that this is still over cos x minus sine x. Yeah, so these should be x's instead of thetas. The one thing you definitely don't want to do, as I wrote that down, I know exactly where people are thinking is cancel, 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 and you end up with cos x minus sine x, which isn't plus, and then you try to figure out how to make it a plus, and a lot of you would just like cancel, 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 and write a plus there and be like, done, see one step, and I did it. And that's where it's weird math magic that doesn't make any sense. We're going to use this piece here. We're going to use our difference of squares factoring that we know and appreciate so much, and by that logic, that means we would have cos x plus sine x. Oh, sorry, why did I write y? It's y because of the thing there. Plus sine x in one bracket. The other bracket's going to be cos x minus sine x all over. Well, and this is like my imaginary brackets here, cos x minus sine x. Now that these are being multiplied up top, I can cancel out the entire bracket from each other, which leaves me with cos x plus sine x. And then my left side is equal to my right side, and I'm happy. So it's looking for these tricks, looking for some factoring things that we've seen before, because there's nothing new there. It's factoring things, it's expanding things, and making them a lot easier. So always try to think about it in terms of the most basic steps, and then you can go back to them in terms of sine and cos, like we were doing. I think we did a little bit Thursday as well, and Wednesday.